In this video, we look at how data is shaped around its central values and what that means for business decisions. We'll focus on skewness, range, quartiles, and simple deviations before moving on to more advanced ideas like variance and standard deviation in subsequent videos. Knowing the shape and spread of data about the variables of interest allows decision makers to estimate the reliability and risks of their decisions. If the data is clustered closer to the center and its variability is low, decisions targeting the average or typical values of the variable are likely to have more impact than decisions targeting widely spread data. Two datasets can share the same central value, like the mean, and yet may behave very differently in practice. One might cluster tightly around the mean, while another stretches from very low to very high values, even though the mean is the same. That hidden spread can change how risky a decision feels and how much buffer you need in budgets, timelines, or capacity plans. Measures of variability help you see that spread clearly. When you understand how data moves away from the center, the business story hidden in your data starts to become visible. But before we jump into the waters of variability, let's take a quick look at the measures of central tendency that we covered in the earlier videos in this section and see how they are related. In a perfectly balanced distribution, mean, median, and mode sit together, giving a neat central picture. But in many business situations, the data is skewed or asymmetrically distributed. A longer left tail implies that lower values are bringing the mean down, while a longer right tail means higher values are dragging the mean up. In a left-skewed situation, the mean value is less than the median, and both are less than the mode. In a right-skewed situation, the mode is less than the median, and the mean is the highest of the three. Skewness is a unit-free way of describing this asymmetry, and it tells you which side of the distribution is creating more risk or opportunity. Notice that this is the main reason why we emphasize not using the word average to describe all measures of central tendency as if they were the same thing. Mean is the arithmetic average of the data. The median is the point that splits data into two equal parts, and mode is the value that occurs most frequently in the data. If we treat them as identical, we are presuming that the data is distributed symmetrically when making decisions. And if you overlook the impact of skewness, you might expend resources in all the wrong places. The range is the quickest view of how far your data stretches. You take the largest value and subtract the smallest value. For business data, this gives you an immediate sense of the most extreme cases you have actually seen, such as the smallest and largest order size or shortest and longest delivery time. If your mean or median values are not near the middle of that range, it hints that outliers may be pulling the data in one direction. While range is simple and easy to communicate, it looks only at the two extremes, so it is best used as an early warning signal rather than the whole story. When you sort your data from smallest to largest, the median is the middle value, where half the observations are below and half are above. Quartiles extend this idea. Q1 is the point where roughly 25% of the data lies below, and Q3 is where about 75% lies below. The segment between Q1 and Q3 captures the middle 50% of your data, which is often where the typical business behavior lives. By thinking in these chunks, you can quickly see whether most of your values are tightly grouped or spread out. In everyday language, we often say getting somewhere might take 15 minutes, give or take 5, which is an informal way of describing deviation from an expected time. Our brains naturally make these judgments when we allow extra time for new destinations, because we expect more variability when we have fewer past observations. This is the same logic that is used in statistics to calculate and interpret deviations. Statistically, deviation is the distance and direction between each value and the mean of a variable. When you say 15 minutes give or take 5, you are essentially saying that you might arrive somewhere within 10 and 20 minutes. The consistent central tendency is given by the mean, 15 minutes. But the deviation of 5 minutes allows the other person to set their expectations more realistically. If you are able to get there in 12 minutes, you essentially had a deviation of -3 from the mean. Similarly, if it takes you 17 minutes, that is a positive deviation of 2 minutes. In either case, your arrival time fell within the give-or-take deviation range you had defined. Now consider that it takes you 30 minutes to get to the location. What do you think happened? Unexpected traffic, closed road, or some external reason you had little control over? Your initial deviation range was based on what is normal or expected, but the additional deviation of almost 15 minutes certainly had a cause that would need to be investigated further. This is how deviations and variability allow decision makers to set expectations and then identify what requires more scrutiny if those expectations are not met. Consider a small sample of sales for 10 weeks. The sales for each week are a specific distance from the mean sales over the 10 weeks. When you subtract the mean from each individual week's sales, you create a set of deviations, some negative and some positive. The negative ones indicate lower sales than the mean, and the positive ones indicate higher sales than the mean. Because the mean is the balancing point of the distribution, the positive and negative deviations cancel each other out, and their sum equals 0. This property explains why we cannot simply average raw deviations if we want a single number that reflects how spread out the data really is. The entire logic of deviations is based on how far a value is from the mean, implying that the sum of all deviations of all values will always be 0. This is because the mean itself is calculated based on each observation in the dataset. To get around the problem of deviations summing to 0, we can take the absolute value or just the distance of each deviation to get only positive numbers. Then, the average of these deviation numbers can be obtained in pure distance terms. In our example, this gives a mean deviation of 3.8 around the mean sale of 26.2. Interpreted in words, sales are about 3.8 higher or lower than 26.2, which indicates that expected weekly sales are between 22.4 and 30 units. This produces a very intuitive plus or minus statement that business stakeholders can easily understand. Although mean deviation is intuitive, it comes with important limits when you move to more advanced analysis. Using absolute values breaks the positive and negative structure that is helpful for deeper mathematical work, especially when dealing with smooth probability curves that require calculus. On large or complex datasets, mean deviation can gloss over meaningful patterns in the spread of the data. This is why statistics often rely on variance and standard deviation instead, which treat deviations in a way that preserves more detail. In the next video, we will build from the basic idea towards measures that support richer probability models and more precise business analysis and forecasting. Central measures like the mean, median, or mode tell only part of the story. Variability shows how dependable those central values really are. Skewness, range, and quartiles help you recognize asymmetry and extremes, which is essential when judging business risk and opportunity. Deviations and mean deviation translate your natural give-or-take thinking into a measurable description of spread. As we move to variance and standard deviation next, these same ideas will support more sophisticated yet still interpretable summaries of your data. For every key business metric, start asking the right questions. Not just what is the average, but how far do values tend to drift from that average, and what does that mean for our decisions?